Hello, this is Dr. VC Sontake, and I am the course faculty for the course Engineering Thermodynamics. Unit 1. The content of the Unit 1 is divided into two parts. Part A is dealing with the basics of thermodynamics, and Part B is dealing with properties of ideal gases. So the detail of the syllabus of Unit 1 is as follows. In Part A, Introduction to Thermodynamics, it includes the topics like basic concepts of thermodynamics, systems and its forms, property, state, process, cycles, thermodynamics, equilibrium, temperature, zeroth law of thermodynamics, introduction to first law of thermodynamics, energy transfer, heat and work, mechanical form of work, and non-mechanical form of work. The part B is all about ideal gas and its behavior, which includes topics like gas laws, Boyle's law, Charles' law, Avogadro's law, equation of state, specific heats, universal gas constant, constant pressure, constant volume, isothermal, isentropic and polytropic processes on PV diagram, calculation of heat transfer, work done, change in internal energy and enthalpy. Objectives of this video lecture are 1. To define and classify thermodynamic system. 2. Define the concept of boundary, surrounding and universe. 3. Explain control volume and control surface. So let us start our discussion with the very basic element of thermodynamics called as thermodynamic system. A thermodynamic system is defined as a quantity of matter or region in space upon which attention is concentrated for some thermodynamic study to analyze a problem. Thermodynamic study means we are studying energy conversion process taking place in a quantity of matter or region in space to which I am considering as thermodynamic system. I can also do the study to find out the effect of energy conversion process taking place inside that particular thermodynamic system and its effect on the property of thermodynamic system. A thermodynamic system may be as simple as a free body or as complex as power plant. For example, let us take a piece of chalk. That can also be a thermodynamic system as simple, or it can be a power plant which includes different types of machineries and infrastructure. Each one of them can be considered as separate and individual thermodynamic system. So thermodynamic system can be as simple and as complex. In the figure, we have considered solid, liquid and gas. All can be considered as quantity of matter, and we can select them as thermodynamic system. Let us consider a room and it is selected for some thermodynamic study. For example, if you select a room to make it air conditioned room, so you have to do some thermodynamic study before applying air conditioners or air conditioning system. So we have to analyze what are the different heat transfer into or out of the room, what is the heat generation within the room. So all these factors we have to take into consideration related with the energy conversion processes So this room can also be a thermodynamic system, and it is region in space. Examples of thermodynamic system: mobile, power plant, IC engine, compressor, and Pelton turbine, that is water turbine. The common feature among all these thermodynamic systems is some form of energy conversion is taking place inside all these engineering devices. For example, in the mobile, we are charging the battery, so electrical energy is storing into the battery in the form of chemical energy conversion process. And while the mobile is being in used, that some part of the chemical energy is also converting into heat. So if you want to select this mobile for its thermodynamic study with the purpose that we want to keep the mobile as cool as possible, the mobile can be treated as thermodynamic system. In power plant, heat energy is converted, thermal energy is converted into electricity. In IC engine, heat energy of the fuel is converted into work output, and so on, so forth. Surrounding. The region or quantity of matter external to a thermodynamic system is called the surrounding. Everything external to the system is considered to be part of the system's surrounding. So let's say we have a 100 kg of mass, and out of that 100 kg of mass, I select only 2 kg of mass for some thermodynamic study. So that 2 kg of mass will be thermodynamic system, and that remaining 90 kg of mass will be surrounding for the system which I have selected for some thermodynamic study. So anything, whether it is a quantity of matter or region in space, external to the system is called as surrounding of the system. Boundary. The region or quantity of matter which is neither part of the system nor part of the surrounding is called boundary. The system is separated from the surrounding by the boundary. The boundary may be fixed or moving and real or imaginary. Please make it note of this. Identification of boundary is must to define system. Unless we are able to define the boundary, we cannot define the thermodynamic system. Universe. System and surrounding put together is called universe. Let us take the illustration of thermodynamic system with the help of example. If we consider a classroom for some thermodynamic study, then classroom is nothing but region or space. So it can be thermodynamic system. Any quantity of matter or region in space outside this classroom will be considered surroundings, like room, any other room other than this classroom, furniture or space will be surrounding to this classroom as thermodynamic system. Now walls and ceilings, they are quantity of matter. Now walls are neither part of the room nor part of the surrounding. So walls and ceiling will be boundary for this classroom, and these walls are separating the room from its surrounding. Now universe is called as system and surrounding put together. So in this case, classroom is system and remaining college campus is its surrounding. So when we put classroom and college campus together, it will be called as universe. Similarly, let us take the example of college premise. If we consider the entire college premise for some thermodynamic study, then it will be a thermodynamic system, building, open space, anything which is there inside the college premise will be thermodynamic system. The fencing of this college premise will be called as boundary because it is neither the part of the college premise nor of the surrounding. And everything external to the system and beyond boundaries will be surrounding of this college premise as thermodynamic system. And college premise plus surrounding put together is called as universe. Let us consider this mass selected for some thermodynamic study. So I can treat it as thermodynamic system. Everything external to this thermodynamic system will be called as surrounding. The quantity of matter which is neither part of the surrounding nor thermodynamic system represented here by blue color will be boundary. This boundary is separating thermodynamic system from its surrounding, and system and surrounding put together is called as universe. Let us take some examples. Here it is a piston cylinder arrangement is shown. The piston can move in the upward or downward direction. So the rigid walls of the cylinders are called as boundary of this piston cylinder arrangement as thermodynamic system. They are rigid boundaries and real boundaries. The piston can move in the upward and downward direction, so it will have moving boundaries and also the real boundaries. Another example, take the example of nozzle. Its outer surfaces will be the real boundaries and they are fixed, whereas boundary on the inlet side of the nozzle and outlet side of the nozzle, they are imaginary boundaries. You cannot see them. For the analysis purpose, you have to assume that boundary exists at the inlet and outlet. So they are imaginary boundaries. The example of system having moving boundaries, the balloon. If you blow the air into the balloon, its surface will expand so as its boundary. When you remove the air from the balloon, its boundary will be decreasing. So balloon is having moving boundaries. So there are different systems with the moving boundaries. Now question comes, is universe example of thermodynamic system? No. Our universe is not the example of thermodynamic system. Now why do I say so? So far, human could not locate or decide the boundary of the universe. And to define or identify a system, its boundary must be identified. Hence, our universe is not an example of thermodynamic system. Now, the reason behind why human could not locate the boundary of the universe, there is a very good example. The spacecraft Voyager 1, it is moving in the outer space with the speed of 60 to 140 km per hour. Voyager 1 is a space probe launched by NASA on September 5, 1977 to study the outer solar system. Having operated for 43 years, the spacecraft still communicates with the Deep Space Network to receive routine commands and return data at a distance of 142.31 astronomical units. So till date, it is 21.289 billion kilometer away from the Earth's surface, and still it is moving in the deep space. And so far, it could not locate the boundary of the universe. That is why universe cannot be treated as thermodynamic system. If you visit this site, you will find the actual location of Voyager in the deep space. Classification of thermodynamic system. Thermodynamic systems are classified based on the energy and mass transfer across the system boundary. Energy is having two forms, heat and work. Now, based upon this criterion, thermodynamic systems are classified as open system, closed system, and isolated system. And based upon the number of phase, system can be classified as homogeneous system and heterogeneous system. Now, let us explain all these thermodynamic systems one by one. So, based on the energy and mass transfer, open system, closed system, and isolated system. Open system. The open system is one in which matter or mass can cross the system boundary in either direction. That is, mass can either enter into the system or can come out of the system boundary. Both the way it is possible. There is energy transfer as well. Energies is having two forms, heat and work. So energy can also enter or leave the system boundary in the form of heat or work. So an open system permits both mass as well as energy transfer. The mass within the system may not be constant, as mass is either leaving or entering the system boundary. It is not going to remain constant. Rather, volume of the open system is going to remain constant. Most of the engineering devices are open system because in some or the other way, they are allowing mass as well as energy transfer across their system boundaries. Open system is also called as control volume system. As I have explained, in open system, mass is continuously changing, but its volume will remain constant. That is why open system is also called as control volume system. So if this is the open system, mass can either enter, mass or can leave. Mass can only enter or mass can only leave. Energy in the form of heat or work can enter or leave in the form of heat or work. Energy can also enter in the form of heat only and can leave in the form of heat, can enter in the form of heat, can leave in the form of work. Energy can enter in the form of work, can leave in the form of heat, and can enter in the form of work and can leave in the form of another type of work. So all these combinations are possible for mass transfer and energy transfer in case of open system. Example, reciprocating air compressor. Here, atmospheric air is entering into low pressure, low temperature atmospheric air is entering into the compressor, and after compression, it leaves as compressed air, high pressure, high temperature air. So mass transfer is there. With regard to the energy transfer, electrical input, electrical energy is given to drive this compressor. So electrical energy is input and some heat is also leaving after compression. So energy transfer is taking place. So this way reciprocating compressor can be defined as open system. Closed system. Closed system is one in which no mass transfer takes place across the system boundary. That is, mass of the system will always remain constant. However, in case of closed system, energy transfer in the form of heat or work can take place. Thus, an closed system permits only energy transfer across the boundaries. It does not allow mass transfer. It is also called as control mass system because mass of the system is fixed, remains constant. If this is the controlled closed system, there will be no mass transfer into or out of the system. Energy in the form of either heat or work can enter and leave as heat or work. Example of closed system is piston cylinder containing gas. A gas is contained within the piston cylinder boundaries and it cannot come out. When heat energy in the form of heat is supplied to this gas will expand, will make this piston to move in the right direction, which will cause this connecting rod to move, to reciprocate it, and will cause this wheel to rotate. And this rotation of the wheel will produce work output. So heat is input, work is output, and mass remains constant. So piston cylinder containing gas is good example of closed system. Isolated system. Isolated system is one in which there is no interaction between system and the surrounding with reference to mass and energy. It is of fixed mass and energy and hence there is no mass and energy transfer across the system boundary. Closed thermal flask is the example of isolated system. Now in real practice, isolated system, no system can behave as an isolated system and practically there is no utility of isolated system. Even if we consider closed thermos flask as example of closed system, it is isolated system only when its lid is closed. The moment we open the lid to get coffee or hot water, the mass will come out and energy transfer will take place. So it will become open system. So if you want to make it thermos flask as isolated system, we have to keep its lid closed and we cannot get coffee or hot water. So what is the utility of such system? So that is why isolated system has got no engineering utility. From utility point of view, open systems are best considered as engineering systems and to some extent closed system. Now further classification of thermodynamic system based on the phase. And based on the phase they are classified as homogeneous system and heterogeneous system. So first let us define phase. A phase is a quantity of matter which is homogeneous throughout in chemical composition and physical structure. There are three phases of substance: solid, liquid and gas. Fourth phase is also there, plasma, but it is not worth to consider that phase. Now, homogeneous system. A homogeneous system is one which consists of a single phase. In order to identify the homogeneous system, the two different substances with same phase form a different substance in which there is no separation line, and these two substances are not physically visible separately. So such system is called as homogeneous system. Example, atmospheric air. Atmospheric air is mixture of so many gases, nitrogen, oxygen, all are in gaseous phase, and they are mixed so homogeneously you cannot identify presence of oxygen or nitrogen in atmospheric air. Similarly, air and water vapor. and water plus nitric acid. Water plus nitric acid all are in liquid phase and they are thoroughly mixed. Similarly, air and water vapor. Heterogeneous system. A system which consists of two or more phases, different phases, is called heterogeneous system. In heterogeneous system, there is a clear separation line and they are physically variable between the two constituent substance. Water plus steam. Water is in liquid phase, steam is in gaseous phase. Both are separated. Ice plus water. Content of sealed steel tube containing liquid mercury or liquid ethyl alcohol and a mixture of saturated vapor of the alcohol and mercury. Concrete is a heterogeneous mixture of water plus cement plus gravel. Water plus cement is a mixture, homogeneous mixture, and this homogeneous mixture will form heterogeneous mixture with gravel. Now, what about oil plus water? Oil is in liquid phase, water is in liquid phase. So will it be heterogeneous system or homogeneous system? So oil is an example of heterogeneous system. Though oil and water both are in liquid phase, but there is a clear-cut separation line between oil and water and you can identify oil and water separately. So oil and water is heterogeneous system. Control volume and control surface. This is a very important concept and we will frequently encounter with this term control volume and control surface. For thermodynamic analysis of an open system such as an air compressor or IC engine or turbine, attention is focused on a certain volume in space surrounding the compressor, known as the control volume, bounded by a surface called control surface. Matter as well as energy can cross the control surface. For example, if I take this compressor, the volume of this compressor I am considering for some thermodynamic study, so it will be called as control volume and it will remain fixed during the thermodynamic study. And the surface which will cover this control volume is called as control surface. I have drawn the imaginary control surface line and matter, that is mass as well as energy, can cross this control surface. Take another example, a car covered by its cover. So the cloth cover will be the control surface and car volume will be the control volume. So this is a rude analogy to explain control volume and control surface. Now, based upon this discussion, let us try to identify following engineering system as open, closed or isolated system and homogeneous or heterogeneous system. IC engine will be open system. Steam turbine will be open system. Because all these are engineering devices and all engineering devices are example of open system. Gas turbine, open system. Water turbine, open system. Pressure cooker. Now if pressure cooker is on gas and it is whistling, so it is allowing vapor to come out into the surrounding. So in this case it will be open system. But when pressure cooker is not whistling and kept for cooling, not allowing any vapor to come out of it, it can be classified as closed system. Compressor, open system. Steam boiler, open system. Refrigerator, open system. Air conditioner, open system. Air conditioned room, closed system if it is properly insulated. No heat will either allow to enter or leave the air conditioned room. Water plus iron bar, heterogeneous system. Liquid plus solid phase. Ammonia plus ice, heterogeneous system. Gaseous plus solid phase. Water plus methyl alcohol, heterogeneous system. Ice cubes in a cola, initially when it is served to you, heterogeneous system. After ice gets melted, it will be a homogeneous system. Earth, closed system, and human body, open system. Because mass transfer and energy transfer takes place across the human body. So after watching this video, the learner will be able to define and classify different thermodynamic systems, able to define the concept of boundaries surrounding an universe, and able to explain control volume and control surface. With this, I come to an end of this video lecture. Thank you for your kind attention and passionate listening. Happy learning.